Hello everyone, I am Dipti Laxmi Bhuyan. I welcome all of you to today's class. The topic of discussion today is atomic structure. So let's begin the topic. Here are some points of discussion. These are fundamental particles, Rutherford's atomic model, atomic mass and mass number, isotope, isobar and isotone. The next one is Bohr's atomic model, Bohr-Bury scheme, then Aufbau principle, Hunt's rule, and the last one is electronic configuration. So let's start with the topic fundamental particles. Before entering into the topic, let's discuss about the history of atomic theory, that is atomic structure. In 1808, a chemist known as John Dalton put forward a theory famously known as Dalton's atomic theory. According to him, every matter is made up of extremely small individual particles known as atom. Here, matter refers to three states of matter, that is solid, liquid and regarding three states of matter we already have discussed in our school days. Then later in 19th century it was found that atom cannot be subdivided further. However, the experiment conducted by various chemists like Rutherford, Moseley, Bohr, Planck and others revealed that atom is not the smallest particle of every matter, and further it can be subdivided into three fundamental particles, basically electron, proton and neutron. This was a historic statement in the field of science. As you can see here in the picture, the atoms are arranged in various states of matter, that are solid, liquid and gas. In solid state, the atoms are closely packed. However, in liquid and gas, they are loosely packed with each other. Let's move to the next topic, that is discovery of electron. Electron was discovered by J.J. Thomson in cathode ray experiment. It is designated by the symbol E-, and electron is an actively charged particle having the value minus 1.6 into 10 to the minus 19 coulomb. The mass of the electron is about approximately 9.11 into 10 to the minus 31 kg, and the radius of electron is 10 to the minus 15 cm. After discovery of electron, let's move toward the discovery of proton. Proton was discovered by E. Goldstein through anode ray experiment. It is designated by the symbol small p or H+. It is a positively charged particle having the value 1.6 into 10 to the minus 19 coulomb, and the mass is about approximately 1.672 into 10 to the minus 27 kg. Before discussing Rutherford's atomic model, let's discuss the history of other atomic model. So, after discovery of electron and proton, it was a great challenge for the scientists to know about the arrangement of electron and proton inside an atom, that is, the atomic structure or atomic model. J.J. Thomson was the first to give the atomic model, famously known as Thomson's atomic model or plum pudding model. According to J.J. Thomson, atom is a positively charged sphere in which electrons are embedded in it, that is studded in it, like negatively charged plum embedded in a positively charged pudding. As you can see here in the picture, the negatively charged electrons are studded in a sphere of positively charged proton, or we can compare it with the watermelon. As you can see, the positively charged proton can be compared with the red part of the watermelon, and the negatively charged electron can be compared with the black color seed inside the red colored watermelon. However, Thomson's atomic model was not widely satisfied and was discarded in later period. After discarding of J.J. Thomson's plum pudding model, various experiments were carried out worldwide in order to reveal the actual structure of an atom. Later, Rutherford conducted an experiment commonly known as Rutherford's gold foil experiment, which helps to reveal the structure of atom in a more accurate manner. So, let's move to our Rutherford's atomic model. The Rutherford's gold foil experiment can be studied in three steps. First, experiment and experimental setup. Next, observation. And the last one is conclusion. In first part, that is experiment part, Rutherford bombarded a thin sheet of gold foil that is having thickness 0.00004 centimeter with alpha particles. These alpha particles are nothing but helium 2 plus coming out of the radioactive material radium. Then a thin lead plate with a hole in it was placed in front of that lead block, as you can see in the figure 1. Then a circular screen coated with zinc sulfide in the inner side was placed on the other side of the gold foil, which helps to illuminate the alpha particle strike on it. After the experimental part, the next step is observation. The observation part includes the events observed during the experiment. In this part, it was found that maximum alpha particles coming out of the radioactive particle, that is radium, straight pass through the gold foil, that is undeflected. However, some alpha particles were deflected in some angle. A very few alpha particle, that is about 1 in 10,000, retraced its path. As you can see in figure 2 and figure 3, there are maximum alpha particle passed straight through the gold foil and some deflected in angle as shown in figure 3, and about just 1 alpha particle out of 10,000 retraced its path. The passing of alpha particle was detected by the illumination of light after striking of the alpha particle to the zinc sulfide coated in the inner side of that circular screen, as you can see in the figure 2 and 3. According to Rutherford's gold foil experiment, most of the space in an atom is empty because in the observation part we have seen maximum alpha particle pass straight through the gold foil. Next, the scattering of alpha particle in all directions reveals that there is a heavy positively charged at the center of atom, which causes repulsion. As we know, the alpha particles are nothing but positively charged particles. When it strikes with the gold foil and repulses back, it was assumed that there must be a positively charged particle present at the center of the atom. He named this positively charged particle as nucleus. And then Rutherford concluded that atom is consist of two parts, nucleus and extranuclear part. Nucleus is an extremely small positively charged part situated at the center of an atom, and the nucleus carries almost whole mass of the atom. That is, the whole mass of the atom is centrified at the nucleus. However, the negatively charged particle, that is electron, is revolving around the nucleus continuously in a circular path. That circular path is known as orbit. Then he said that there are two types of forces existing, that is centripetal force and centrifugal force, which balances the revolving of electron around the nucleus. This Rutherford's model of atom can be compared with the solar system. As you can see in the figure 4, it represents the Rutherford's atomic model. Here, the center is occupied by positively charged nucleus where almost all mass is centrified, and the negatively charged particle, that is electron, is revolving around the nucleus in a circular path, which is known as our orbit. This model is also known as your planetary model. So, this is all about Rutherford's gold foil experiment. We will continue the chapter in the next video. I hope all of you understand the topic we discussed today. Thank you for watching the video. See you soon. Goodbye.